Okay, so we have to solve this equation cos 2 theta plus sine theta minus 4 is equal to 0. And we're going to find the general solution for this. Okay, so we have cos and sine part of the same equation. We have to get rid of one of these functions. And the way to do that is to change this cos 2 theta into one of its double angle identities. Now the double angle identity I can use would be this one, the one that has a sine in it, and only a sine in it, because that would help me solve this equation. If I chose the one with cos, or the one that has both cos and sine, we are just complicating the equation further. So that's why I'm choosing this one. Now I'm going to add up my like terms. This 1 can be added with the negative 4. That should give us negative 3. And then also what I'm going to do is I'm going to change the signs of everything. So if I multiply this whole left-hand side and the right-hand side by negative 1, all the signs will change. Okay, so this negative 2 becomes a positive 2 sine squared theta. This will become a negative 7 sine theta. And remember, this was negative 3, so that will become a positive 3 now. And even the sign of 0 changes, but positive 0 and negative 0 is the same thing. Okay, so now we have this trinomial with sine. Okay, and I'm going to factorize this trinomial by finding the factors of this first number 2 and then the last number 3. And that's actually easy because the factors of 2 and 3, they are prime numbers, so it's just 2 and 1 and 3 and 1. Okay, so 2 and 1, it becomes 2 sine theta and 1 sine theta. Okay, let me just write it a bit bigger. 2 sine theta and 1 sine theta. The factors of 3 is 3 and 1. And I'm going to put the 3 over here and the 1 over there. Because if I multiply this 2 with the 3, I want to get 6. And the 1 with the 1 to give me 1. 6 plus 1 will give me the 7. Okay, or negative 6 plus negative 1 gives me negative 7. Okay. Now I can go further to solve this by making each bracket equal to 0. So if this bracket is equal to 0, you would simply take the 1 across and then divide by the negative 2. Or just divide by the 2, which gives us a half. And here you'd simply just take the 3 across. So sine of here is equal to 3. Okay, what I was going to say about this step here, this step where we factorize, if you don't like doing that, you can just use the quadratic formula. So your b, remember, is the negative 7. You can just say negative 7 plus minus the square root, and you just fill in everything there. Okay, it will give you these same answers. Perfect. Now we need to solve theta, because this is just sine theta. We won't be able to find a solution for this because already we can see there's an answer that's greater than 1, and sine can't be greater than 1. So here's no solution. Okay, this one we can solve. The reference angle for a half is 30, and I know sine is positive in the first and second quadrant. So in the first quadrant, it would just be 30 degrees. Theta is equal to 30 degrees. And in the second quadrant, theta is equal to 180 minus 30 degrees, which is 150 degrees. Okay, and then for both of these answers, let's not forget to write plus K360, because that's the period of a sine graph. And so these answers will repeat every 360 degrees.